right, so we should be able to graph an equation in slope intercept form already, to be fair. You did it in 7th, 8th grade in algebra. Probably did it in geometry. They were asking me how, I can't remember for sure. But mostly we want to see, start getting an idea of how we can use graphing linear equations in slope-intercept form to graph or model real-world situations in business and finance. I mean, that is what we're doing here. So this first page, talking about maintenance fees for 2 different banks. One maintenance fee is $5, one is $1. And then we're talking about the out-of-network fees or charges. So many banks charge for out-of-network ATM use. Out-of-network ATMs are ones provided by someone other than your bank, which you might have to rely on if you're in a town that does not have your local bank branch near you. It could be even something like you're all the way across town. Maybe there's not an ATM that's in the network with your bank. It says compare the following account fee structures. So the monthly maintenance fee of $5 for one. Every time you use an out-of-network ATM, it's $2 for that bank. Hometown National, Freedom Bank, your maintenance fee of $1. Every time you use an out-of-network ATM there, it's $3. So which one's a better deal? Okay, so Freedom. Okay, Freedom. What, Ezra? That $2 adds up. Anybody else? Please chime in. So let's think about it. What if you use out-of-network ATM 20 times? Which one's going to be better? So that's what we're going to kind of think about, right? So if you know you're not going to be traveling on a network, maybe Freedom is a better deal. But really, we can't say one or the other for sure. It depends on how often you use that out-of-network ATM. So is one bank always better? Well, we pretty much just answered that. No, it's not. And we're going to use a G table to see when one is cheaper than the other. How many times do you have to use an out-of-network ATM before Hometown National Bank is actually a better deal, right? And so these are the decisions you're making when you're picking a bank as well. You don't want to just pick the one at first that looks like, oh, it's a lower maintenance fee, right? It's not always necessarily a better deal because there may be other features with that plan or at that bank that cost more that you're maybe going to use. So if you don't ever use an out-of-network charge, ATM rather, then the Freedom Bank would definitely be your best choice. Given the information that we have, which is just these two things, maintenance fee and out-of-network ATM. So I've got a key table, and you guys are going to create a key table. Somewhere on there. So this is the Freedom Bank key table. This is the Hometown National Bank key table. So if you use an out-of-network ATM one time, how much would it cost you at Freedom National Bank for that month? $4, right? One plus the $3. How much would it cost you for Hometown National Bank? Right. So 5 plus 2 times 1. How much would it cost you at Freedom National Bank for 2 ATM out-of-network charges? 5. So 2 times 3 is 6 plus 1 is 7. How much would it cost you for Hometown National Bank? Right? Because that is 4 plus 5 is 9. So I'm going to save you the math of these. Freedom Bank, if you use it 3 times, it would be $10. So Freedom Bank is still a better deal, at least up to 3 out-of-network ATM fees. So at 4 $16, right? Here, 5 times 2 is 15 plus 5 is $15. So we can see, based on this table, up to 3 charges out of ATM, out of network ATM charges, Freedom Bank is definitely a better deal. But after 4, so 5 or more times, then a hometown national bank would actually be a better deal for you, even with that higher maintenance fee. So let's say you chose Freedom Bank, right? How could you make sure when you're away at school next year that you don't have a lot of these out-of-network ATM charges? What could you do to avoid those extra fees? Go to the ATM for your bank. Well, what if you're in the stinky Gainesville? What if you go to school there? What if you did it there? Huh? Get more cash out at one time, Ezra? Get cash back from someplace that doesn't charge you. Yeah. Any other ideas? I mean, Gainesville is pretty yucky, but they probably have banks there. Right? You could open a bank in Gainesville, right? You can have 2 banks. Your parents can deposit money electronically if that is something that they are going to be doing for you next year. Or you can transfer money from the Tallahassee bank to your Gainesville bank. Or you can just close your Tallahassee bank and open a Gainesville bank, right? So you have options. If you pick the one that has a higher fee, you don't necessarily have to incur those fees. You have options. Use a cashback option for your debit card, or like Ezra said, you can go to some stores. Some businesses may charge for cashback. I don't use a debit card, which makes me pretty old and crusty. I just don't use one. So I'm not super familiar with who charges what, but I know that sometimes establishments will charge extra for using credit cards. Those credit cards are also a good option for this because if you guys know that if you pay your credit card off every month, you don't have to pay any interest on it? Yeah, my dad. Yeah. Now sometimes there's an annual fee with a card, but there are plenty of cards that there is no annual fee to. You can also, if you have that option, credit cards get a bit of a bad rap because some people have a hard time managing that access to a lot of money, but they can be a really good tool if you use them correctly. All right, so how can you best compare the 2 fee structures? Well, we did a T-table, but also graphing on the coordinate plane, which is what you're going to do in your homework. Oh, man. We are just going to go over together today graphing. You are going to graph based on a business model on your worksheet. We're just going to review the actual graphing part. Your worksheet, if you're looking at your worksheet, you see there's look at that front page. I think you're going to have to graph one. Don't keep it together, Emily. Keep it together. But all 3, you are going to graph 3 lines on one graph. Had somebody last period ask me, where's the 0? So if you're looking at this worksheet for today's work, the 0 is in the bottom left-hand corner. They're only showing that top right quadrant of the coordinate plane. Y'all caught up with me? Yeah. Okay. Yeah. All right. There's a little video. I think there's a live link in your digital copy here. We're not going to watch it. But if you need a little help at home when you're working on your assignment, that is one place you could go. So this problem is already done. It says graph the equation. Remember, we're graphing linear equations. Linear equations must be aligned. That is the definition of a linear equation. When you graph it, it will be aligned. You can write the equation from the line, right? So y, this is an equation written in both intercept form. Remember that's y equals mx plus b. We did review this on Friday. Where this is the slope, or the rate of change, and this is the y-intercept, or the beginning value, initial value, right? So if we're graphing an equation, The best form of linear equation to graph from is the slope-intercept form. And just the name of it tells you can see the slope and the y-intercept at a glance. When it's in this form, you don't have to do any work to find the slope and the y-intercept. So what is the slope of this line? The slope of this line, Lawson? 1/3, 1/3. Yep. And what's the y-intercept of that beginning value, Madeline? Yep. So if you are graphing a linear equation, slope-intercept form, the very first thing you're going to do is make sure you can identify the slope and the y-intercept. The very next thing you do, when the coordinate plane, you're going to plot the y-intercept. And it's always on the y-axis. Remember, this is the y-axis, the vertical line that goes to 0, goes to the origin. When you plot this number, it's always on this line. And you can see we said it's 4, and there's a dot on 4. So think B for beginning is the initial value based on a real-world problem, and it's also where we're going to begin to graph from. We're going to use the slope. The next step says we're going to use the slope to plot additional points. So we're always going to start at the y-intercept, and really we're looking at the slope equals the rise over the run, where the rise tells you how far to go up or down, and the run tells you how far to go left or right to get to each new point. Remember, if you go up in the coordinate plane, that rise is positive. If you go down, it's negative. If you go right, it's positive. If you go left, it's negative for the run. And here this just tells you that the numerator tells you how far to go up or down, which that's your rise. So that's your rise. And the denominator of the slope fraction is your left or right movement. So that is your run. You notice it talks about your fraction being a slope. If it's not a slope fraction already, we can turn any number into a fraction just by putting it over 1. You turn any number into a fraction, putting it over 1, Katie said. She's right. Y'all caught up with me? On the last but not least, you have to draw a line. So if you don't draw the line to the point, you have not, in fact, graphed it. You slide the point to graph it, but you got to draw the line through the point. Please use a straight edge. That's just be your worksheet or your notes to draw your line. Please make sure it's going to have arrows going left to right. Now, in your problem today, in your worksheet, you don't have to draw, well, it's fine. We're just going to stay with that. Y'all clear with me? Okay. So we're going to use these steps to graph this equation, y equals -5 times x plus 1. So what is our slope? I got that. What is our y-intercept? You guys fill in the slope, fill in the y-intercept. What did you get for the slope, Chantal? Very good. -5/2. And since you're going to want the y-intercept, that's exactly right. I'm going to say your name on over the video. Chantal to Chantal. Got the off. Sorry. I haven't done her name. I'm going to call me Madeline then. Would that be okay? I'm going to call her the right name. Don't give me a hard time. Just remind me I forgot the R. Okay? Sorry about that. Sincerely. Okay. Sincerely and Madeline. But I want to make sure I call Chantal. Okay. Here we go. So plotting the y-intercept. So this is the y-intercept, right? The 1. It's got to be a point on the y-axis. There's not a number on all of these. That's okay. We count up from that origin. That's 0. That's 1 on the y-axis. Positive 1. From here, we're going to use the slope. So the slope. Now this negative is in the middle there. We're going to put it either in the top or the bottom. In fact, we're going to wind up putting it in both. Not at the same time. Yeah. Right. So first off, we're going to start with a negative 5 in the numerator, positive 5 or positive 2 in the denominator. And that tells me from the y-intercept, I'm going to go down 5 because it's down is negative, and then I'm going to go right 2. So from here, down 5, right 2, that's how I know to put my next point. I'm going to do that starting here now. Go down 5. Did I go down? Yeah. 5. Can't see from back there. My glasses. Oh yeah, so 10 is at the bottom. All right. Oh, not there. Don't put your foot there. Go down 5 and then to the right 2. Now I would keep going, but I'm running out of space. I can't go down 5 and then right 2, right? But we want points all the way across this coordinate plane. So I can rewrite this slope, as long as it's equivalent, I could rewrite it as 5 over negative 2. If you put either of these things in the calculus, you get the exact same thing. They're both negative 2.5. But here, now with the y-intercept, I'm going to go up 5 and to the left 2. Up 5 to the left 2. Up. Can't go up 5, so I can stop there. And now we're going to draw the line to those points. It's much better job than I normally do, just let you know. So, you can not draw the line if you don't draw a line. And don't draw a line here in the middle. Alright? We want it to go from one edge of the coordinate plane to the other. Okay? So the next two graphs we're going to do them together. It says do with a partner. I keep trying with a partner and partners are failing. We're going to try the partner for the second two. The next two we're going to do together. So if you flip it over, there's two more equations. I think there's a y-intercept the same again, but the slope is different. So we've got two equations side by side, two coordinate planes side by side. We're going to graph them both, and we're going to look at the slope. We're going to use these steps. We're going to identify the slope and the y-intercept, and let's just go ahead and do it for both. The slope and the y-intercept, the slope and the y-intercept. So remember, if the equation solve for x, like these are, solve for y, the y by itself, the number being multiplied by the x is the slope, the constant being added to that term is the y-intercept. Okay? So what is the slope of equation from A, Kylan? 2. And what is the slope from equation B? Here. The slope from this one? Yeah. What's the y-intercept for graph A? Yeah. Right, so 1, right. What's the y-intercept for graph B, Savannah? Perfect. So we we have two lines that have the same y-intercept, so they're going to go through that same point on the y-axis, but they have different slopes, so that's what we're going to look at. So we identify that we're going to plot the y. So let's plot the y here. And I'm going to plot the y-intercept here. Atlas? What's wrong? No, it's one. The y-intercept is one.
Oh, we just
Or negative 2, right? Now we're going to concentrate on that positive 2 slope. All right? We have done the first two steps for graph A. Now the next thing is we're going to use the slope in fraction form or rise and run form to plot more points. So this slope is not in fraction form right now. How can I make that a fraction? Just put it over 1, right? So 2 over 1 means up 2 to the right 1 and beginning at the beginning at the B. So go up 2 to the right 1. Up 2 to the right 1 until we get to the edge of our coordinate plane. Up 2 to the right 1 until we can't do that anymore. We want that all the way across our coordinate plane with this exercise. So what can I do to get points down here? Everybody remember? Can't flip it. I can rewrite it as an equivalent fraction though, right? That would take me down from the y-intercept. So negative 2 divided by negative 1, doesn't that equal positive 2? Right, so now I can go down 2 to the left 1 from that beginning dot, our B, or y-intercept, down 2 to the left 1, down 2 to the left 1, all the way off the edge, or to the edge of our coordinate plane. All right, and then we have to draw the line. If you don't draw the line, and you have not graphed a linear equation, because the graph of a linear equation is a line, not a collection of points. So you guys remember what the slope of a line means? Tells us about the line. What does the slope of a line tell us? Slope. You go to the t-slope. What do you think of? What do you think of slope? How fast is slow? How about how steep, right? If you've ever been to a steep slope, the black ones are super steep there, right? The bunny slopes are not as steep. They're way steeper. Yep, way steeper. I don't know why they call them the black. They're usually almost always the black. They're just coated with colors, right? So I was putting those. I didn't make it up. That's just what it is. I don't know. I have no idea. Okay. So the steepness is what the slope refers to. How steep is the line, right? So do you think this line is going to be less steep or more steep than this line? So this is a positive 2, this is a negative 2. You think it's going to be less steep? Well, let's graph it and see. Graph it and see. So we've got our slope, but now we need to write it as a fraction. So we're going to write it as negative 2 over 1. And that means we're going to go down 2 into the right 1. So down 2 to the right 1. Down 2 to the right 1. Oh, yay, I got this in already. Down 2 to the right 1. But I don't have any points up here. So now I can rewrite, I can just move that negative. I can make it a positive 2, over -1. That is an equivalent number, right? Equivalent fraction. So but now I can go up to and to the left one, so I can fill up points on the other side of our coordinate plane. I'm going to go up to the left one. Until I get to where I can't do that anymore. And now I'm going to draw my line. So what do you think? Is -2 less steep? Austin says yes. What do you think? So to go from here, I went up to over 1. To go to here, I went up to over 1. All right? I think it's the same steepness, but it's going in different directions, right? We're going up the mountain and down the mountain, right? But they're the same steepness. That's what this book tells us. How steep is the line? One positive, one negative slope can be the same steepness, and they are. If it's the same value, the same absolute value, they have the same steepness. So how do those slopes compare? Well, they are the same steepness. They're going in different directions, right? In different directions. So we're not going to say that uphill and downhill. We're going to say that they both look like they're uphill to me, but there's something we need to distinguish about that. So look at the slope that's going up. The bottom up top on the same thing on the right one, the -2. It's going up, right? But in algebra, in math, when we're talking about the slope, we're looking at the direction it goes from left to right, just like you're reading a book, right? So this positive slope is going up from left to right. This negative slope is going down from left to right. All right, see if you guys can do these two. So identifying the slope and the y-intercept first. Now, what is the B? Albert, where's the on there? Right? You guys compare. All right. Start here. Up one to the right two. Up one to the right two. Okay, great. Got it. Layla, you're taking Anna. Then did you finish prepping yours? Layla, you're taking Savannah. Oh, you went down one and over three. Did you? Or like kind of how much time did you down one over one? Yeah, you went a little bit too far. I probably am doing that if you're having a hard time getting time. You gotta make sure. Now we're gonna put one. We're not quite ready.
Okay.
Yeah. Has are your questions? Here's a yearbook. Right, identify the exposure stuff too. Yeah. Yeah. So Nathan says you have to do all the errors and stuff. You don't have to do the errors and stuff when you do it. I'm doing that just to remind because not everybody is super comfortable with it. So I'm writing the slope of the. I would like for you to identify the slope of the line intercept if you don't want to draw errors like that. But I do want points all the way across the coordinate plane. Okay? And then we're not done with this. Okay. We're plotting the y-intercept for both. Not everyone's finished, so I'm going to put it up here real quick. I should have saved one of my earlier periods. Oh, that's okay. So positive 1/2 means up 1 and to the right 2. So the first part of the coordinate plane. Up 1 to the right 2. Up 1 to the right 2. Up 1. Really hate not to have space. Okay. But I need more points here. So remember, we can rewrite that slope as a different fraction. We could write it as -1 over -2 as well. Down 1 and to the left 2. And then last but not least, if you don't draw a line here, you have not graphed a linear equation. I don't mind if it goes a little bit off, it just can't, it's got to go all the way across. So the same y-intercept, we started at the same point, but now we're going down 1 and to the right 2, down 1 to the right 2, down 1 to the right 2. So now we have points here. Our y-intercept we already said was 1. That's where we started. And we can move that negative from the top to the bottom. So now it's a +1 over -2. Now we're going up 1 and to the left 2, always starting at that y-intercept. Once we get away from that y-intercept, then we just go up to the next point. slope is like our GPS to the next point. So what have we noticed about the steepness of these lines? Is one more steep than the other? They're not, right? Even though this is a smaller coefficient. One is not more steep than the other. I don't know what to say about that. Same thing, they're the same steepness. They cross the same point, but one is positive and one is negative. So how does this sign positive, negative affect the graphical equation? So we talked about it. Remember what we said? Positive slopes. What does that look like on the coordinate plane? To the right. It goes down to the right? Down to the left? No. So it goes up from left to right. So it goes up from the bottom left to right. So as you go right, it goes more up, right? The negative goes down from left to right. That's how we want to think about it. Positive slope, line goes up from left to right. Negative slope, line goes down from left to right. So if we just had the slopes of two lines, how would we know which one is steeper if it's not graph? Well, look at your slope of 2 and slope of 1/2. Which one is steeper? 2. Look at your slope of negative 1/2 and positive 2. Which one is steeper? Negative 1/2. 2 is still steeper, right? The 2 and negative 2 have the same steepness. Negative 1/2 and positive 1/2 have the same steepness. Those values, 2 and negative 2, have the same absolute value, right? Negative 1/2 and 1/2 have the same absolute value. So we're going to compare their absolute values. If we want to know 1/3 and negative 4, those are slopes of two different lines. Which one's steeper? Well, the one that has the greater absolute value is steeper. The one that has the smaller absolute value is less steep. Did you already write that, Katie? I think that was the last thing. And submit your notes. And then we do have about 5 minutes to work, so at least look at what I was talking about. You're graphing all 3 lines, all 3 of the equations on the same coordinate plane on the bottom, and you're going to be answering questions about that graph. I think once you get them all 3 lines are going to go on the same coordinate plane, and that is okay. Make sure you label each line when you graph it. And the worksheet is due tomorrow at 7. Remember, you can turn late work in up to the day of the test. So if you haven't done something, that doesn't mean you shouldn't do it. Go ahead and do it.